Most people think USB-C is just a charging cable. They're wrong. Every time you plug one in, something extraordinary happens before your device even begins to charge. In less time than it takes you to blink, your laptop and charger silently identify each other. They negotiate exactly how much power can be delivered. They verify whether the cable is safe enough to carry that power. They configure ultra-high-speed communication channels, and they decide whether this connection will charge a battery, transfer massive files, drive an 8000 display, connect an external GPU, or perform several of those tasks at the same time. None of those decisions are made by you. They happen automatically, in complete silence, before the first meaningful flow of power ever reaches your device. So today, we're going to slow time down, millisecond by millisecond, to reveal the invisible engineering hidden inside every USB-C connection. The instant the connector touches the port, nothing dramatic happens. No surge of electricity, no battery starts charging, no files begin to transfer. Instead, an incredibly precise sequence quietly begins. Every metal contact inside the connector is engineered to make contact in a specific order. That order protects delicate electronics from unwanted voltage spikes and prepares both devices for everything that follows. Before USB-C can deliver power, it must first establish a safe electrical connection. Almost immediately, another process begins. The connector determines its orientation. Unlike older USB connectors that only worked one, USB-C is fully reversible. Special contacts detect how the connector has been inserted, allowing the controller to internally map every signal to the correct destination. Whether you insert it upside down or right side up, the electrical pathways are automatically rearranged so the connection behaves exactly the same. Now, the real intelligence of USB-C comes to life. Through a tiny communication pathway known as the configuration channel, both devices begin exchanging information, not through software, not through Wi-Fi, not through Bluetooth, but through carefully encoded electrical signals. The charger announces what it can provide. The device responds with what it requires. Within microseconds, they determine which side will supply power, which side will receive it, what communication modes are supported, and whether advanced features can be enabled. Only after both sides fully understand each other does the next stage begin. Power negotiation. A smartphone may only require a small amount of energy. A gaming laptop may require more than 100 watts. USB-C never assumes. Instead, both devices negotiate the safest voltage and current using USB power delivery. They may begin at 5 volts before requesting higher power levels such as 9, 15, 20, or even more under the latest specifications. Every increase must be accepted by both devices. If either side disagrees, higher power is never enabled. This negotiation protects both the power source and the device from potentially damaging electrical conditions. But the conversation still isn't over. The cable itself now becomes part of the decision. Not every USB-C cable is built to the same standard. Some are designed only for charging. Others can safely carry much higher power while transferring enormous amounts of data. Premium cables often contain a tiny integrated circuit called the e-marker chip. This miniature controller stores detailed information about the cable's electrical capabilities, maximum current, supported data rates, video compatibility, and advanced USB4 features. Before unlocking higher performance, connected devices, read this information to verify the cable can safely handle the requested workload. If it cannot, the entire connection automatically limits itself. The weakest component always defines the maximum capability of the system. With power negotiated and the cable verified, USB-C configures its high-speed communication lanes. Multiple differential signal pairs become active. Depending on what has been connected, those same electrical pathways may carry USB data, DisplayPort video, USB4 traffic, or Thunderbolt communication. Nothing inside the connector physically changes. Only the assignment of those high-speed lanes changes. One connector becomes many different interfaces simply by configuring how electrical signals travel through its internal conductors. Now, for the first time, the connection begins doing what you actually notice. Power flows into the battery. Files start transferring. The monitor comes to life. An external SSD appears. A keyboard responds instantly. Everything feels immediate. But behind those familiar actions, billions of electrical transitions are racing through microscopic conductors every single second. At these incredible speeds, even tiny imperfections can distort a signal. Engineers overcome these challenges using differential signaling, controlled impedance, precision shielding, equalization, and advanced signal conditioning circuits that preserve every bit from one end of the cable to the other. This also explains one of the biggest mysteries surrounding USB-C. Two cables may appear completely identical, the same connector, the same shape, sometimes even the same color, yet one only charges a phone, another powers a workstation laptop, transfers data at extraordinary speed, drives multiple high-resolution displays, and supports advanced accessories simultaneously. The difference isn't visible from the outside. It's hidden within the cable itself. Additional conductors, higher quality shielding, stricter manufacturing tolerances, advanced internal construction, and, in many cases, the tiny marker chip that silently tells connected devices exactly what the cable is capable of handling. What appears identical on the outside can be entirely different on the inside. Every time you plug in a USB-C cable, an invisible engineering process finishes before you even notice the connection has begun. Devices identify one another. Power is negotiated. The cable is verified. Communication pathways are configured. Only then does electricity begin delivering power, data, and video exactly as requested. USB-C isn't simply a charging connector. It is a communication system, a power management platform, and a high-speed digital network integrated into a connector small enough to fit on your fingertip. The next time you plug an USB-C cable, remember that long before your battery starts charging or your screen comes to life, an extraordinary conversation has already taken place in complete silence.